e to the I pi plus 1 equals 0. One of the most famous equations in mathematics because it relates so many interesting numbers. 0 was once forbidden in Europe because it was thought to represent the void, or nothing. And nothing is a really scary concept, and for a while people wanted to believe that nothing did not exist. 1 is a simple number, the first of the counting numbers, and because of this, it too has so many interesting properties. Pi, in contrast, is from geometry, and its value has been approximated since at least the time of the Babylonians, making it older than even 0. I is the mysterious imaginary number. It was created by mathematicians who were tired of their equations falling apart at the square root of a negative number, and it resulted in this whole new complex plane with all sorts of weird stuff going on. And E, or Euler's constant, appears in many areas of mathematics, but it's extremely useful for natural exponential growth. Unlike the exponential growth of, say, compound interest, where you get your interest once every month or every year or quarter, natural exponential growth is continuous, so it goes gradually over time instead of in just one moment. And it's described by some transformation of the equation y equals e to the x power. And that's what makes this equation, Euler's identity, really cool. How do all these cool numbers fit together so well? Why does e to the I pi plus 1 equal 0? How do you even take a number to an imaginary power? It all starts with the Taylor series, which is a way of writing one function as a sum of many other functions. So here's the Taylor series of a few functions. And I know this looks a bit complicated, but you can ignore most of the notation for now. The main thing to notice right now is the fact that over here, you can't really plug in I because you don't know how to take a number to an imaginary power. But here, it's just powers of x, and you know how to take powers of I. So I'm going to make this e to the iy. And move things around a little bit. And as you can see here, this is just the Taylor series for cosine. And this is the Taylor series for sine. So e to the iy power is just the cosine of y plus I times the sine of y. So now what happens if we plug in pi here? Well, the cosine of pi radians is negative 1, and the sine of pi radians is 0. So e to the I pi is negative 1 plus I times 0, and that's just negative 1. And since negative 1 plus 1 equals 0, e to the I pi plus 1 also equals 0. Isn't that amazing?